My name is Esfahani. I'm the Director of Human in the Loop System Lab in the Department of Mechanical and Aerospace Engineering. Our lab is focusing on integration of the human and the robotic system in a teamwork where the performance of the team is maximized and optimal. In order to ensure the optimal performance of the human-robot teamwork, we are looking at understanding human intention, human cognition, and mostly utilizing physiological information, brain activity, muscle activity, heartbeat, and such, in order to extract that information and inform the robot in order to adjust its behavior. We also work on different aspects of the safety when it comes to the human-robot interaction, whether it's a physical interaction or it's a teleoperation. We are specifically designing end effector which are utilizing compliance in order to enhance the safety. And all of these systems are basically have an AI system in the back end, which is adjusting the controller based on the human intention and how the human is reacting to these robotic systems. There are multiple different trends. One of them is personalizing the autonomy. If the robotic system or the AI in general learn how to adapt to a specific human and learn from that interaction in order to adjust their interaction with the other human, which is mostly a transfer learning. In order to do that transfer, this is another thing which is also needed and is missing currently, is a digital twin for this human-robot interaction, being able to learn from multimodal information in real time and updating that digital twin in order to make this adaptability seamless. I think is going to be a very important direction that currently the research community is taking. When human works together, they have a perception model of their interaction. So for instance, I know if I speak in a specific way, my audience are going to react in a certain way. So having that perception, I can control and I can adjust the way that I'm communicating with them. It is essential for the robotic system to have that model perception of the human behavior and act accordingly. When it comes to the ethics and the trust that you mentioned, one of the main issues is how good that model is. And when we develop that model, did we consider enough samples or enough representation from different communities? Are we just basically making robotic system who knows how to interact well, certain age group or the certain backgrounds? That is something that needs to be studied well. When you want to conduct any sort of experiment with a human subject, of course we go through IRB, but the sampling is going to be the key point in order to make sure we adjust this kind of fairness and inclusiveness across different populations. So I'm teaching 3 different courses, which are robotic system, manufacturing automation, human-robot interaction, and probability and stochastic processes. In all 3 courses, I provide a lot of examples from the research projects that we are doing, not just my own research projects, but other research projects that are ongoing on campus or even different universities, to motivate the student and make that transition from theory to practice much easier for them. Currently, we have multiple different projects, and I can talk about those projects. One of the PhD students in my lab is working on a physical interaction between robotic system and soft matter. This interaction is specifically very challenging because the soft matter can change material properties. So having a good understanding of the soft matter behavior is a key in order to optimize the behavior and the way that the robot is interacting soft materials. And that soft materials can be a biological materials or let's say fresh produce. Another project that we have is integrating shear force for in-hand manipulation. We basically underestimate how difficult manipulation is. If I want to demonstrate something as simple as changing the manipulation in your hand required changing the point of contact, understanding if something is sliding or not. We are working with another faculty who's developing shear sensing system, and the student is working on learning from human the best strategy for in-hand manipulation. We have another project on multimodal physiological understanding of the human behavior, and this is specifically for teleoperation when human is interacting with multiple different robotic systems. And the idea is to understand that and then utilize large language model in order to optimize the interaction and the dialogue for explanation between the explanation of the task between the human and a robotic system. Wherever I go, I try to see if there is any new food that I have not tested before. If I cannot find something new, I will definitely go find some Persian food and kebab. That is something definitely to go for.